Welcome back. This is lesson 11A. In this lesson, we won't do any programming. We're going to discuss a particular style of programming and how it works. And then in lesson 11B, we'll actually start writing the programs. In this lesson, I want to review what Object-Oriented Programming, or OOP, means. As a quick overview, it means that the facts that we store normally as variables in our programming up to now are going to be stored as attributes of objects, and those objects are going to be grouped together into classes of object. So that seems like a lot of more work than what we're used to, but I'm going to conclude by explaining why this is such a good idea that it's widely used in modern programming. Up to now, we've always stored different values as individual variables, and if we want to group them, we've grouped them into data structures such as lists or 2D arrays. And there's an example on the screen right now. In the Gorgatron game, we wanted to store a group of monsters. So each monster's values are stored as a list, and then that list is stored inside a bigger list. And if we want to talk about the particular attributes of the monsters, here, for example, printing out the monsters' names, we have to refer to it by number. So name is value 1 in each of the it's value 0 in each of the sublists. So going through the list, printing attribute I, which is the index number 0. So it'll go through every monster, printing out their name. To write programs like this, we have to remember what number value is associated with each of the different facts about the monster. In real life, facts don't just float about in the world, do they? They're always linked to objects, and the same goes for the imaginary world of a game. So we don't just have strength on its own, it's always the strength of something. We don't have names existing on their own, they're always the names of something. And this is true whether we're writing a game or whether we're writing a program to work with the real world. Every fact is linked to an object, and this is how object-oriented programming works. So to recap, when we're working with 2D arrays or similar structures to store the data, each fact is given a number, and we have to remember what those numbers mean as we write and read our programs. So in this example, print the attribute 3 of a variable called monster. Or in this example, go through the entire stock list, and for each stock value, print attribute 0 and attribute 2, whatever they are. But in object-oriented programming, our facts are given names and they are linked to other variables as attributes of those objects. So here I'm clearly printing out the strength value of the object monster. Or here I'm going through the entire stock list and I'm printing out the name and cost of each item of stock. So this makes our code easier to read and easier to write. But it gets even better than that, because we don't have to redefine the attributes every time we want to make a new object in our code. Because again, we're drawing on features of reality. In reality, or in the world of a game, objects don't just exist at random, but they typically are grouped into classes. So in our game, we might have a group of monsters, or if we were writing a program for a bank, there would be a large number of customers. And those customers are not just wildly different from each other. They've all got certain predictable characteristics like an address and a bank balance, and so on. So we create, in object-oriented programming, we don't just think about what the attributes of our objects are, but we group those objects into classes, and that greatly simplifies our task when we're writing our programs. So let's recap what I've just been talking about. Instead of storing values as individual items and grouping them just into numbered lists, we store values as named attributes of particular objects. And to make our life even easier, we create classes of objects which all have the same attributes, and this makes our coding much easier. The name for this new method of coding is object-oriented programming. It's been around for a couple of 2-3 decades now, and it is extremely popular in modern commercial programming. Okay, there are some disadvantages. It means you can't just get stuck in programming straight away. You've got to plan and think carefully, what are the objects that my program is going to work with, and what are their attributes. I've got to sit and write the code to set up those classes before I begin programming. Also, it kind of relies on this feature that I was talking about before, that we have groups of objects that are very similar to each other. There may be examples of programs that we're writing where that doesn't apply, and in that case some of the advantages of OOP wouldn't apply. But this extra work at the beginning shouldn't put you off, because once you've set up your code, there are lots and lots of advantages. As you've already seen, it makes your code easier to read because instead of numbered attributes, we've got named attributes. Doing this work at the start to set up our classes and our objects makes less work for us in the long run, and it gives us better control over the things that happen in our program as it develops. You remember I've spoken to you about how modern programming is done very much in large teams, and there is always a danger of miscommunication and errors occurring because the different people in the team don't know what each other's code is doing. But if they're all using the same objects with the same attributes, this greatly reduces the chance of these kind of unforeseen errors occurring. So it's very good for modern programming that's done in teams. So the verdict is that object-oriented programming is definitely worth the effort, and it is extremely widely used. It's used a lot in computer games. You'll notice that the games you play typically feature objects which vary in their particular details, the details of their attributes, but have a lot of similarities. Think of the players in FIFA. They've got differences, but overall the player type of character has a lot of similarities as well, and it applies to all kinds of games. So I've used some vocabulary here, and it's important that you remember the meanings of these words. So have a look at those right now and see if they ring a bit of a bell. So what we're talking about when we're making OOP programs is data values are stored as attributes of objects. They're not just floating about or collected into numbered lists, but they are named attributes of objects. And those objects are instances, that means kind of like examples, instances of larger classes, and all the objects within that class, although their details may vary, they share the same general attributes. So to recap, facts are stored as attributes of objects. You're going to create a class of objects and define what their attributes are, and then create objects as instances of that class. And I hope you've understood from my overview why this approach is used in most modern programming. So next lesson we'll actually start doing this, but I just wanted to give you an overview. The other thing I want to mention is that storing values as attributes isn't the only thing that happens in OOP. We also create methods within the classes, and we'll also get onto that in a lesson or two. So let's take it steady, because it's an extremely useful kind of programming and we're going to do a lot of work with it from now on. I'm going to leave you with some homework if you're my student, and the homework is to play a computer game. Can be any game, like Tetris is a good example for instance. Play any game that you like and see if you can work out what the objects are. And there may be more than one class of object in your game. Have a think about that and consider what attributes of the object are stored by the game. For instance, hit points or colour or whatever it is that they store. Okay, so next lesson, 11B, we're going to start writing OOP code. Okay, bye for now.